This is the example that you have on the handout. It is an optimization problem. There are two variables, number of dogs and number of cats. There is an objective rule kind of embedded in here. It says the owner makes $40 profit on each dog and $30 on each cat. There is a graph already provided. And this is the part of the problem that makes this new. It says that the owner has to close part of the boarding house, which means that she cannot accept more cats than dogs. Based on this change, by how much will her maximum profit change? Okay, so you have the steps of what to do in your handout. This is the first one. It says, solve the problem normally without the new constraint. That's the can't have more cats than dogs. Now, in this case, some of this work is already done because we already have a graph with the original constraints. We don't have the objective rule written out, but it was in there. It was that sentence that said how much profit the owner made for cats and dogs. There's the profit. And what we don't have is before the new constraint. We don't have a list of these vertices, and we don't have a list of the profit at each one. So let's write those in. The vertices are A has coordinates 8 and 4. Because we don't have the rules, we don't have to solve for the points of intersection. We can just read them off the graph. B is 8 and 15. C is 12 and 15. And D is 16 and 8. And for each one, I'll plug it into this objective rule. Find the profit by doing 40 times x plus 30 times the y coordinate. So this is what those work out to be. You can verify them if you like. It means that this point here, C, corresponds to the point that yields the maximum profit before the new constraint. Because the question asked by how much did the maximum profit change, we have to find the maximum profit before, and we have to find the maximum profit after. So that's the before part. That's done. Step 2 is to add the new constraint to the same graph. This is the part of the problem that has the new constraint. It says the owner has to close part of the boarding house, which means that she cannot accept more cats than dogs. That is the new constraint. So that new constraint has to be written out. In this case, it means that y, the number of cats, cannot be more than, it's got to be less than, or it can be equal to the number of dogs. And I'm going to add that to the existing graph. So here's a zoomed in version of that graph. I'll take that new constraint, and either you want to write it as y equals x plus 0, you can make a table of values, which is how I usually do it, or you can work with the initial value being 0 and the rise over run being 1 over 1. You can graph it that way as well. In my table of values, if x is equal to y and x is 0, y has to be 0. If x was 2, y would have to be 2. And if x was, let's say, 5, y would have to be 5 as well. So I'll take my 3 points. Again, if you were working with the initial value and rise over run, you would get a similar looking line connected through all of them. You still have to figure out which side is shaded. I can't use 0, 0 here because the line passes through 0, 0. So let's say 0, 2. You can pick any point that's not on the line. When I plug that in as my x and y into the original, it's got to be the original one with the inequality symbol. It says that 2 is less than 0, which is false. So this side that has 0, 2 is not the side that's shaded. This side is. Everything below the line. That's here. Now this line and constraint combine with the existing polygon of constraints to mean that if this had to have been the shape before, and this is the line with shading afterwards, that this becomes the new polygon of constraints. This part is gone. It doesn't meet the new constraint. And that also means that this, while B and C are gone, it introduces new vertices because this red shape is the new polygon of constraints. It's going to have 2 new vertices that we haven't worked with yet. There's one here, which we'll just call, let's say, E, because we've got E, C, and D, and this one over here, which we'll call F. So the next steps are to find the coordinates of the new vertices, which you might have to solve. Depending on the situation here, we can read them off the graph. And you'd have to plug in those new vertices into the same rule. So 2 things are happening here. Points B and C are gone. They're no longer valid. They don't meet the new constraint. And there are two new points, E, whose coordinates I can read off the graph, and F, whose coordinates I can read off the graph. And I'll plug those into the same profit rule as before. That was the one that was 40x plus 30y. So I'll plug those in and find the new values. And with the new points, A, D, E, and F, the only ones that are still accurate and appropriate after the new constraint, using those ones, I've got to come up with the new maximum profit. It turns out to be this one. Before, my max profit was 930. Now, my max profit is 910. So to answer the final question, that's step 5 on your handout, the answer is that the owner's profit decreased by $20 with the change. That's it.